Maximum subarray. Medium, 20 minutes. I definitely have 20 minutes, but sometimes the medium ones throw me for a loop, so... yeah. Okay. Given an integer array nums, find the contiguous subarray containing at least one number, which has the largest sum, and return its sum. A subarray is a contiguous part of an array. We did something very similar to this in a different problem. What problem was that? I can't even remember now. Where we had to keep track of the minimum to the maximum. And we saved off the minimum each time it changed. And we did the maximum of the current min, whatever the current min, minus the prices of the current price. Yeah, and I actually changed this code based on Clippy. And I didn't update it here. That's fine. Yeah, for price and prices, iter skip one. That was Clippy's suggestion. So I think this is similar in that, here it is. We need to keep track of where we are and run up, keep a running sum, and then based on whatever that sum is, we keep track of the maximum sum, right? So we can start off sum of 0, whatever the current sum is 0. We hit this and it's -2. So now our best value, our best sum is -2. Then we can add the next one. So now it's -1, right? And then we want to keep track of whatever the maximum value of the current running sum is. Right? Because now if we add -3, well, -2 plus 1 is -1. If we add in -3, that's going to make the current sum smaller. So we're going to ignore it in terms of our sum, in terms of our summation. And we'll keep -1 as our current best sum. Right? And then we add 4. Nick Forces says starting with int64 min. Yeah. So yeah, so for the best one we want to do that. Okay, so let's get cranking. That's not a bad idea. Let's start with our lib. This is 53. Oh, it's a very low number. LC 0053 maximum subarray. Pub struct solution return 0, and we have a test mod test. So this is solution maximum subarray bang of this, and somehow this is going to return a 6. I forgot to close the paren there. There we go. What's this complaining about? Oh, max subarray. Like that. There we go. Okay. So I think you're right. I think we want to start off best is equal to well, this is I32s. So we'll do this I32 min. And what we can do is say we can keep track of whatever our current sum is. And we can just loop through the array for x in nums. Now this is, the answer to this problem here is 6. 4 minus 1 is 3, plus 2 is 5, plus 1 is 6. Right. So we're going to keep track of whatever our current best sum is. And so once we get to this point here, we know that our current best sum here is -1. We don't add in the -3, and then it's going to be 4. So we'll start off with 4 then, because 4 is better. What's the constraint? Nickforce asks. Font size is too small. Oh, sorry. How's that? Oops. Why did I do that? The constraints, the length is up to 10,000 numbers, and we have, yeah. Yeah, so everything is in I32 here. So that's what I was basing it off of. So we can say the current sum is equal to, it's either going to be if we have a value that's bigger than our current sum, then that's going to start off a new best value. Let's say n in nums. I don't know why it said x. So there's n max of cur sum plus x, n. Right? Because -3 plus n is going to be smaller than the -1 that we have. So that'll store that. And then we just keep track of the best by saying best is equal to best times max cur sum. And that'll just keep running, whatever the maximum we found overall. And this will just be the maximum of whatever our current max is going to be. Right? Because as soon as we hit, so cur sum plus n is going to be 3, so we're going to keep the 4. And then 2. This should do the trick if I did this correctly. And then we just return whatever the best is. Yeah, that passes. And we can actually show that. Let's put 0 here. And that way we can print out our current, considering and best cur sum best so far equals best, and we can watch it as it does it. Oh, I forgot this. My hands just slip off the keys in the middle of typing. Yeah, so the best so far is -2. The best so far is 1, right? Because 1 is the maximum there. And then -3, we're considering -3. Our best so far is still 1. And our running sum total is -2. We hit the 4, and now our best so far is 4. We see -1, 3. Our best so far remains 4. We add the 2, because between these two numbers, right, then the 3 is bigger. Here the 5 is bigger, so now we get that. Here's the 6 is bigger, so now we get that. -5 is not bigger than 1, so now our current sum is 1. And then 4 and 5, and our best so far remains 6. Right. So I think that's all we need to do. I think there aren't any corner cases we have to worry about. Oh, there is this corner case that we have to worry about. Duh. We have to worry about an empty array. Let's do the example 2 here, which just has a single entry. Max sub array. Back bang 1. And expecting this to be a 1. Oh, right, I got to put this back. Yep. And then we can do this one. I don't know what's special about this one versus the first one. It's just a little shorter. And I'm doing these backwards. See, this says expected and actual, and I'm doing actual followed by expected. I don't think it matters. 23. Okay, so that passes. So that was a lot simpler than I thought it was going to be. I think this is the most efficient way to do it. I can't think of a better way to do it. All right, max subarray. And I think that completes, yeah, that completes week 2. Very nice. All right, so in the next stream, we'll start off with these. These are all mediums. When do they get, when do they start getting hard? Medium, 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 medium. Ooh, hard. Minimum window substring. Serialize and deserialize a binary tree. Ooh. I just want to take a peek at that one. Don't worry, I'll forget by the time we get here. Codec. Input-output format is the same how Leetcode serializes a binary tree. You do not necessarily need to follow this format, but so be creative and come up with a different approaches yourself. Oh, I see. So to basically say, okay, convert the... So we do have to fix the tree node code in order to get this one, but this is not for until week 8. All right. So we finished week 1. We finished week 2. The next stream, we're going to start tackling week 3. Let's commit these changes. Actually, the next stream, we're going to start by fixing the tree node code so we can get proper tree nodes. Problem 53, maximum sub array. Here we go. Git push. And let's take a look here. Yeah, there we go. Look at all we did. 1, 2, 3, 4, 5, 6, 7 problems in one stream. One an hour and a half stream. That's not too bad. I can live with that. All right. And our next stream will be insert interval, whatever that does. Thanks for hanging out with me, everyone. I hope you enjoyed. I had a great time, and I will see you in the next stream. Take care.